Okay, I'm facing south again, just as I was, I don't know, what, an hour ago or something. And the sun is just beginning to rise to my east, looking straight up. I don't see the moon anymore there. In fact, the moon is now over there, like another 5 degrees. The moon is gibbous, or gibbous, again. Still, just as before. It's probably another 70 degrees to the horizon on the west side, moving about 110 degrees down. We see the sun just rising. I'm catching the sunrise right now. It was just not there just 1 moment ago. In fact, when I say 1 moment ago, I mean less than 60 seconds ago. In fact, I'm watching it rise. In fact, the intensity is changing right now as I'm looking at it. So all of a sudden, the sun is just getting really bright. See that moon? That's what the gibbous is reflecting. It's reflecting the sun at that angle. Now the sun is probably almost right over the horizon. So is this a coincidence that the moon is happening to point at the sun? What does that mean? This is more than 90 degrees. So we're looking at, like, if that's 90 degrees, how many degrees is that? If we're gonna say 10 or 15 degrees, then this is at least 100 degrees, maybe 105 degrees. So down to the horizon is 70 degrees or 75 degrees. If this is 110 degrees. So this is an obtuse angle. And now all of a sudden the sun is almost, let's see if I can help us see the size of this sun. I can't, but I will go get my X-ray film that's exposed, and we'll see what size the sun is right now. Okay, I'm back, facing south again. Now I'm looking up at the moon again. You can see the gibbous. This is my exposed X-ray film. It shields light very well, as you can see. Can't see that. See the size of the moon compared to this sheet? I guess we can't because this is zoomed in. Here, let me zoom out real quick. Oh, I just dropped this. Okay, that's what the moon looks like right now. Here's my X-ray film going over to the sun, which is really bright, and blocking it. Look at the size of the sun. See that? No matter how far I move this away, if I hold it out as far as I can hold it, see that little marker, the 5 little squares? Look at the size of the sun. That's the size of the sun. If I remove it, if I try to put my finger on it, it's really hard to see. So that's why I use this during the eclipse, because you can actually see the size of the sun. Now tell me if that size is any different than that, apparently, in terms of degrees. They're both about 0.5 degrees of our vision. If this is an entire 180 degree view, that represents about 1/360th of the whole sky from east to west. So does the sun right now. So what does that mean? If you accept the fact that the sun and the moon both take up about 0.5 degrees of our sky, and that's why they can eclipse, because of their distance compared to their size. If you accept that, as you've already accepted previously, then you're going to accept that the sun is not any further away on the horizon than it was when it was up in the sky. See that? So there really isn't, I don't see how there's a way around this. How do you get around that? And why would we think that the moon is self-luminescent when, look at the face of the moon. It's over 90 degrees. It's an obtuse angle with the sun, and it's showing us a gibbous. It's showing us a gibbous, and it just happens to be at about the right angle from the sun. Why would we think that the moon is self-luminescent? The sun is being eclipsed by like a tree. I guess it hasn't, or isn't. I don't know if we can prove that or not. So, I don't know. I mean, to me, that sun, when it's up there, is going to look just the size of this moon, approximately. And as I demonstrated a couple days ago when I went to the horizon there, it looked about the same size. So it's not like that sun is any further away than it was before. And the reason for that is we rotate. We're rotating into the sun right now, and we're going to rotate away from the moon at like 11, almost noon today. And tomorrow, or tonight, when I see the moon rise, I'll take some film of that, and the moon will be pointing down into the ground somewhere, which refutes the flat Earth hypothesis, because according to your hypothesis, the sun's going to be over there somewhere below the horizon, but the moon is going to be pointing down into the ground, like down there. And I'll demonstrate that later at like after 10 p.m. So I hope you've enjoyed this film. Thank you.